Well, a pleasant morning to one and all. This is Venkat Reddy from Triple Department. Today my topic is about a presentation on discussing about a difference between AC and DC distribution systems in the stream of power systems. Well, and coming to next slide, AC versus DC distribution systems, a detailed comparison. So today I am here to compare to alternating current and direct current. Well, alternating current and direct current are two primary methods which can deliver electric power to the consumers. And coming to the power system structure, it would be like generating, transmitting, distributing, and consuming. So this is the basic structure. In that, today we are talking about distribution. In the distribution, we are talking about type of distributions. Well, there are two types of distributions. There are AC and DC, which can deliver electric power to the consumers. While coming to AC, which have dominated power distribution for overall asymmetry, DC systems are experiencing a resurgence due to advancements in power electronics and the growth of renewable energy sources. This presentation will delve into the fundamental differences and advantages and disadvantages of both systems, that is AC and DC, highlighting their respective applications in modern power networks. So in this slide we are discussing about fundamentals and advantages and disadvantages of AC and DC and highlighting their applications to the modern power networks. Next, coming to next slide. What so yeah, one down. What's meant by AC and DC? So what's the basic and fundamental difference in AC and DC? Well, and coming to AC systems which can utilizes sinusoidal voltage and current waveforms that periodically reverse directions. This characteristic allows for efficient voltage transformation by using transformers, which is critical for long distance transmission. AC can transmit AC can transmit and which can minimize losses by stepping down the voltage to high levels, then stopping it down to the same distribution to consumers. And coming to DC distribution, DC systems which can maintain a constant voltage and current direction, while DC transmission avoids the skin effect and reactive power losses associated with AC. Voltage transformation is more complex and historically less efficient. Transformation is more complex and historically less efficient. Modern DC systems employ solid state which can convert the which can use converters for voltage adjustment for improving efficiency and controlling. Well, and coming to the next slide. Efficiency and losses in transmission. AC efficiency. AC transmission which can benefit from efficient and power and relatively inexpensive transformers to step up voltages for long distance transmission which can minimize the copper losses. However, AC systems is also suffering from skin effect, skin effect and reactive power losses, reducing overall efficiency. And coming to DC losses, this transmission minimizes the skin effect and reactive power losses which can be significant in long AC lines. However, DC requires more complex and costly conversion equipment which can introduce the additional losses direct current, that is HVDC. HVDC is nothing but high voltage and direct current, which can be used for over very long distances. And coming to the next slide, what are the basic advantages of AC distribution systems? So In AC distribution sector, what are the basic advantages? It has voltage transformation, established infrastructure and mature technology. Well, voltage transformation which can allows the efficient voltage to step up and step down, crucial for long distance transmission and safe distribution. Well, and coming to established infrastructure, AC infrastructure is well established and widely available, making it cost effective for many applications. Well, and coming to mature technology, that means evolution of technology in AC distribution. AC technology is the mature with a wide range of equipment and exposure available versatilely. And coming to advantages of DC distribution systems, and coming to the advantages of DC distribution systems, which can reduce the losses and integration of renewables energy sources and improved control. Reduce the losses. How we can reduce our losses? DC transmission minimizes skin effect and reactive power losses, and particularly beneficial for long distance or underground cables. And coming to integration of renewables, DC systems are well suited for integrating energy sources like solar and wind, which often generate DC power. And coming to improved control, how we can improve? DC systems offer improved control over power flow and voltage, enhancing the grid stability and reliability. Well, and coming to applications of AC distribution, residential and commercial and industrial applications and long distance transmissions and grid integration. AC distribution remains the dominant choice for numerous applications due to its well-established infrastructure and cost-effective residential homes to supporting the heavy industrial machinery, and AC systems provide a reliable and versatile solution. However, DC distribution which can be used for applications. And coming to applications of AC distribution, which can be used for residential and commercial and industrial applications and long distance transmission and grid interconnection. Residential and commercial in the sense we can use in standard power for homes and business. And coming to industrial applications, and which we can use it for powerful motors and machinery parts. And coming to long distance and transmission, which can be used for transmitting bulk power over long distance. That means we are transmitting the high amount of power long distances through in transmission lines. And coming to grid interconnection, which is connecting the different AC grids together. Grid interconnection. So this is the connecting of so this is the one type of grid and one type of grid which can be interconnected. And coming to future trends and hybrid systems. So in this smart grid, we are observing that power plant, factories, solar power, commercial buildings, and hydroelectric plant, and smart transportation and grid management, and smart houses and power plant. So here we are developing in these teams future trends and hybrid systems, smart grids. Smart grid in the sense we can use it for integration of DC microgrids between AC networks for enhanced control and resilience. And coming to DC homes, which can be emergence of DC appliances and power distribution within home for improved efficiency. And coming to hybrid systems, is in the sense which is the combination of AC and DC components which can be used for high efficiency, which can be performed in diverse applications such as in industrial and And coming to applications of DC distribution, DC distribution which can be used for data centers, electric vehicles, and HVDC transmission lines. Data centers, powering servers and networking equipment by high efficiency. And coming to electric vehicles, which is used for charging infrastructure for electric cars, buses, trains, and e-scooters, bikes, and so on. Moving vehicles. And coming to HVDC transmission lines, HVDC stands for high voltage direct currents. High voltage direct currents. Long distance transmission with minimal losses. Industrial and domestic and commercial. And coming to next slide, what are the synopses of this entire presentation? What we have discussed till now, and what is the conclusion of this our entire presentation? AC and DC distribution systems which can easily possess unique advantages and disadvantages, making them suitable for different applications, and AC systems benefit from mature technology and established infrastructure, while DC systems which can offer reduced losses and improved control and seamless integration of renewable energy sources. As power electronics continue to advance, hybrid AC or DC systems are likely to become more prevalent, offering the best of the both worlds. The future of power distribution will involve a more integrated and intelligent approach, leveraging the strengths of both AC and DC technologies to create a more efficient and reliable and sustainable energy infrastructure. So this is my basic and detailed comparison of AC and DC distribution systems in the stream of power systems. So thanking you one and all for giving this a wonderful opportunity. Thank you.